So this is where we left off for the first part of these notes. And again, if you missed anything, you can Google the unit circle. And all we've done so far is convert degrees to radians, which are, I know you've already learned, but now we're getting to the point where we need to memorize. So what we're going to do next is figure out the ordered pairs for all of these. And again, it's best to know the ordered pairs with radians, because when we get to calculus, everything is in radians. However, the way I like to teach this is starting with the fact that we know the unit circle has a radius of 1. And I also like to teach this just by knowing degrees and knowing the first quadrant. So, the way I'm going to start this is this ordered pair is with a radius centered at the origin. Let me write the center is at 0, 0. Radius is 1. That means the way to get to this point, it just has to go to the right one. So that's the ordered pair 1, 0. Pretty easy, right? We can also do that going straight up. Pretty easy. 0, 1. Now this is where it gets difficult, and I might kind of bounce back and forth between this slide and other slides to explain this. And I'm going to start with in the middle. The in the middle is a different rule than the other two. So I like to start with what I perceive to be somewhat easy. Now remember, the radius is 1. And without thinking of this as pi over 4 radians, which it is, but that's we're kind of getting there, is we can go back and think about this as being a 45-degree angle. And while we're talking about that 45-degree angle, that also means that up here needs to be a 45. We have a 45, 45, 90 right triangle. Well, think about what's the rule for a 45, 45, 90 right triangle. Is to get to the hypotenuse, you have to multiply by root 2. Well, we don't know the leg. That's what we're trying to figure out. So to go backwards, we have to divide by root 2. And that's what we really care about. Maybe I haven't done a good enough job explaining this, but to get the ordered pair, we have to go to the right x units, call this x, and we have to go up y units. So if you think of it this way, the x coordinate is this leg, and the y coordinate is this leg. Well, it's a 45, 45, 90 triangle, so both of these must be the same. So what that means, let me just write it up here, is x is equal to 1 divided by root 2. Except we want to rationalize the denominator. So how do we rationalize? I'm assuming you know how to do this. Please let me know if you are confused. It could be in a Google Meet, or you might just Google that how to know that pi over 4 is the ordered pair, root 2 over 2, root 2 over 2. And again, they're the same because the x and the y coordinate have to be the same for this to be a 45, 45, 90 triangle. If base angles are congruent, then these legs have to be congruent. All right, I don't want to over-explain that, so I'm going to stop right there. And I can explain this one the same exact way. And again, all we know is that the hypotenuse is 1. Now remember, this is pi over 6. And what it was in in degrees was 30 degrees. Well, now what we have is let me squeeze it right here, a 30, 60, 90 triangle. And what we learned in the previous unit about a 30, 60, 90 triangle is the short leg is half of the hypotenuse. So as I write out the ordered pair, well, which one is the short leg? The short leg is across from the 30-degree angle. So that means the y-coordinate, the up and down distance, is half of the hypotenuse. Well, that's easy, because half the hypotenuse is 1 half. 1 half of 1 is 1. 1 half. Half of 1 is 1 half. Now, how do we get the long leg? I guess in a 30, 60, 90 triangle, in this case, x is the long leg. It's the short leg, which is 1 half times root 3. Well, we would just typically write the root 3 into the numerator. So it's root 3 over 2, comma 1 half. And I can do the exact same work for pi over 3. Just changing colors a little bit for you. Because the degrees for pi over 3 is 60 degrees down here, which means up here is 30 degrees, which means it's still a 30, 60, 90 triangle. And the main difference then is the x and the y coordinates switch from pi over 6. And I covered that up by accident in explaining that. So as a reminder, we can fill out everything else in the unit circle just by knowing the first quadrant. Because the reference angles need to match. And maybe I'll do a few dots over here. Because notice that the y coordinate, if I move over here, is the exact same. It's the same height. And what about the x coordinate? As we look at that from that reference angle, it's the same x coordinate except it's reflected. So this ordered pair at 2 pi over 3 is just going to be negative 1 half root 3 over 2. Over here, negative root 2 over 2, positive root 2 over 2. At 5 pi over 6, it's negative root 3 over 2, positive 1 half. And this ordered pair over here, which I hope makes perfect sense, that it's negative 1, comma 0. And I can do the same exact reasoning getting into the third quadrant. Again, remember our rules. You might want to rewatch the first video, or maybe you can Google if you don't like my reasoning for any of these. But if we're in the third quadrant, not only is the x coordinate negative, but so is the y coordinate. So negative root 2 over 2, negative root 2 over 2, negative 1 half, negative root 3 over 2, 0, negative 1. And then the same thing goes into the fourth quadrant. This time x is positive again, but now we have a negative y value. And at any point, what we can actually do is figure out sine, cosine, and tangent, and secant and cosecant and cotangent at any of these values and know the exact values for each of those. And by the way, if I've gone too fast, you are more than welcome to Google the unit circle or watch somebody else explain it, or you can rewatch my video, and maybe in our Google Meets I can talk a little bit more about how you can memorize these values. And yeah, and I think I'm going to stop this and just start a new video just so keep these somewhat shorter than normal.